And JC1 Truth. Today we're going to talk about group 17, which are the halogens.
The colors of the halogens going down the group will become darker. Fluorine will be pale yellow, chlorine will be green or yellow, bromine will be orange or brown, and iodine is black or gray when in solid state, but purple in its gaseous state. As the size increases, there are more electrons going down the group, so there is a greater opportunity for stronger instantaneous induced dipole forces arising within molecules. Hence, they require more energy to break the intermolecular forces between the molecules going down the group. This is also the reason why iodine is solid and fluorine is gas at room temperature. So the melting point and boiling point decreases going down the group. The volatility of halogens will decrease going down the group. This is because the number of electrons of the halogen molecules increases, and more temporary dipoles can be set up, and the strength of van der Waals forces increases. When the melting and boiling point increases, the halogens become less volatile.
So this is the reactivity of halogens going down the group. It decreases going down the group because halogen atoms need to gain one more electron to achieve a noble gas structure. So as it goes down the group, the size increases, meaning there will be more shells, which also means more shielding effect too. So the ability to gain electron decreases down the group because as the distance increases, the force of attraction to attract the electron will decrease as it is shielded by the extra shells. Next is the electronegativity. It decreases down the group too, because going down the group, the distance between the nucleus and the bonding electrons increases, which also means more shells and more shielding effect. So therefore, the electrons are attracted less strongly by the nucleus.
Displacement reaction basically means a more reactive element displaces the ion from the less reactive one. The reactivity decreases going down the group 7, thus bromine will displace iodine. The equation is given in the Jamboard. However, there's a difficulty in seeing clearly the observation of the reactions. So we use cyclohexane as halogens are able to dissolve well in this immiscible substance. A purple color is then observed. Now moving on, we have the reaction of halogens and hydrogen. For hydrogen with fluoride, they react explosively even in cool, dark conditions. For hydrogen and chloride, they react explosively in sunlight, where hydrogen and bromide react slowly on heating. For hydrogen and iodide, forms an equilibrium mixture on heating. Thermal stability of these hydrogen halides decrease down the group, meaning it would take more energy and heat to decompose hydrogen fluoride and hydrogen chloride compared to hydrogen bromide and hydrogen iodide.
The thermal stability of hydrogen halides decreases because atoms increase in size going down the group. This increases the distance between the nucleus and the bonding pair of electrons, so the bond length will also increase. This leads to requiring less energy to break the bond, so less heat is needed to break the bond. And there are multiple ways to test for halide ions in a laboratory. We can first dissolve the compound in dilute nitric acid and then add a silver nitrate solution. This will form a precipitate which could be silver chloride, which is white in color, silver bromide, which is cream, or silver iodide, which is yellow in color. These substances can be tested further by adding dilute or concentrated ammonia solution. Silver chloride can dissolve in dilute ammonia and concentrated ammonia to ammonia. Silver bromide cannot dissolve in dilute ammonia but can dissolve in concentrated ammonia, while sodium iodide remains insoluble in both solutions.
The length of HBr and HI is longer so that it will decompose if it reacts, if sodium bromide or sodium iodide reacts with hydrogen, with sulfuric acid, which means that it won't form and it will decompose to something else. It's shown here. The sodium bromide will at first form hydrogen bromide, but will then decompose to form bromine, which is why we can observe we can see brown fumes being produced. Next, for sodium iodide, will form hydrogen iodide and then form other substances, which is sulfur dioxide, sulfur, and hydrogen sulfide, which produces the purple vapor yellow solid on that fake smell. Lastly, we're going to talk about disproportionation reaction, which simply means self-reduction oxidation. You can see here that chlorine is reduced and oxidized at the same time when reacted with sodium hydroxide in different conditions.